Welcome to the fourth lecture on trigonometry. Stay tuned and receive your lecture on trigonometric identities. I am your lecturer, Professor E.O. Efanga. The fundamental trigonometric identities. The first fundamental trigonometric identity is cos squared theta plus sin squared theta is equal to 1. Proof. Draw a right angle triangle ABC with angle ACB equal to theta. The opposite side AB equals to C. The adjacent side BC A, and the hypotenuse side AC B. By definition, sin theta is equal to C over B, that is opposite over hypotenuse, and cos theta is A over B, adjacent over hypotenuse. Then cos squared theta plus sin squared theta is equal to A over B squared plus C over B squared. This is equal to A squared over B squared plus C squared over B squared. The LCM is B squared, so this will give us A squared plus C squared all over B squared. By Pythagoras theorem, A squared plus C squared is equal to B squared. So this is equal to B squared over B squared, which cancel out to give us 1. So therefore, we have shown that cos squared theta plus sin squared theta is equal to 1. Dividing the first fundamental identity through by cos squared theta, we have cos squared theta over cos squared theta plus sin squared theta over cos squared theta is equal to 1 over cos squared theta. Cos squared theta will cancel out to give 1. Sin squared theta over cos squared theta is tan squared theta. And 1 over cos squared theta is sec squared theta. So this will give us 1 plus tan squared theta equal to sec squared theta. This is the second fundamental trig identity. Next, dividing the first fundamental identity through by sin squared theta, we have cos squared theta over sin squared theta plus sin squared theta over sin squared theta is equal to 1 over sin squared theta. Cos squared theta over sin squared theta is cot squared theta. Sin squared theta will cancel to give 1. 1 over sin squared theta is cosec squared theta. So this will give us cot squared theta plus 1 equal to cosec squared theta. This is the third fundamental trig identity. Example 1. Prove that the square root of 1 minus cos x all over 1 plus cos x is equal to 1 minus cos x all over sin x. Proof. Note that in proving an identity, we have to either start from the left hand side and show that it is equal to the right hand side, or we start from the right hand side and show that it is equal to the left hand side. Here, let us start from the left hand side and show that it is equal to the right hand side. The expression inside the square root sign can be expressed as 1 minus cos x all over 1 plus cos x equal to 1 minus cos x all over 1 plus cos x times 1 minus cos x all over 1 minus cos x. That is, we multiply and divide by 1 minus cos x. Multiplying the numerator, that will give us 1 minus cos x all squared. And multiplying the denominator, that will give us 1 minus cos squared x. So this will give us 1 minus cos x all squared all over 1 minus cos squared x. But 1 minus cos squared x is sine squared x. So this will give 1 minus cos x all squared all over sine squared x. Taking the square root of both sides, we have square root of 1 minus cos x all over 1 plus cos x is equal to the square root of 1 minus cos x all squared all over the square root of sine squared x. But the square root of 1 minus cos x all squared is 1 minus cos x, and the square root of sine squared x is sine x. So this will give us 1 minus cos x all over sine x. Example 2. Prove that tan squared x minus sine squared x is equal to sine 4x times sec squared x. Proof. Starting from the left hand side, tan squared x minus sine squared x is equal to sine squared x over cos squared x minus sine squared x over 1. Taking LCM, which is cos squared x, and factoring out sine squared x, which is a common factor, we have sine squared x into 1 minus cos squared x all over cos squared x. But 1 minus cos squared x is sine squared x. So this will give us sine squared x times sine squared x all over cos squared x. Sine squared x times sine squared x will give us sine 4x. So this is equal to sine 4x times 1 all over cos squared x. But 1 all over cos squared x is sec squared x. So this gave us sine 4x sec squared x. Example 3. Prove that 1 plus sine x all over cos x is equal to cos x all over 1 minus sine x. Proof. Let us start with the left hand side. 1 plus sine x all over cos x is equal to 1 plus sine x all over cos x times 1 minus sine x all over 1 minus sine x. Thus we will multiply and divide by 1 minus sine x. Multiplying out the numerator, we have 1 minus sine squared x all over cos x times 1 minus sine x. But 1 minus sine squared x is cos squared x. So this will give us cos squared x all over cos x times 1 minus sine x. Cos x will cancel cos squared x to give us cos x. So this is therefore equal to cos x all over 1 minus sine x. And that ends the proof. Example 4. Prove the following identities. A. Cos 90 plus theta is equal to minus sin theta. B. Sin 90 plus theta is equal to cos theta. C. Cot 90 plus theta is equal to minus tan theta. D. Tan 90 plus theta is equal to minus cot theta. E. Cosec 90 plus theta is equal to sec theta. And F. Sec 90 plus theta is equal to minus cosec theta. Proof. Without loss of generality, we assume that theta is acute. Thus, 90 plus theta is in the second quadrant. Let us consider a right angle triangle ABC with angle BAC equal to theta, then angle ACB is equal to 90 minus theta. A. Cos 90 plus theta is equal to minus cos 90 minus theta. Since 90 plus theta is in the second quadrant, and we know that cos is negative in that quadrant, and to find the trig ratio for the angle in the second quadrant, we have to subtract the given angle from 180. So 180 minus 90 plus theta is 90 minus theta. But in this triangle, cos 90 minus theta is equal to sin theta. So this will therefore give us minus sin theta. B. Sin 90 plus theta is equal to sin 90 minus theta, since sin is positive in the second quadrant. And in this triangle, sin 90 minus theta is equal to cos theta. C. Cot 90 plus theta is equal to minus cot 90 minus theta. In this triangle, cot 90 minus theta is equal to tan theta. So this will therefore give us minus tan theta. D. Tan 90 plus theta is equal to minus tan 90 minus theta, since tan is negative in the second quadrant. In this triangle, tan 90 minus theta is equal to cot theta. So this is equal to minus cot theta. E. Sec 90 plus theta is equal to minus sec 90 minus theta, since sec is negative in the second quadrant. And in this triangle, sec 90 minus theta is equal to cosec theta. So this will therefore give us minus cosec theta. And F. Cosec 90 plus theta is equal to sec 90 minus theta, since cosec is positive in the second quadrant. And in this triangle, sec 90 minus theta is equal to cosec theta. So that ends the proofs of our identities. Example 5. Given that x is equal to 1 minus 2 cos t and y is equal to 2 plus 3 sin t, prove that x minus 1 over 2 squared plus y minus 2 over 3 all squared is equal to 1. Proof. In the first equation, make cos t the subject of formula. That is, cos t is equal to x minus 1 all over minus 2. In the second equation, make sin t the subject of formula. That will give us sin t is equal to y minus 2 over 3. Now, squaring both sides and then add, we have x minus 1 over minus 2 all squared will give us x minus 1 over 2 all squared plus y minus 2 over 3 all squared. This is equal to cos squared t plus sin squared t. But by the first fundamental trig identity, this is equal to 1, which is what we were asked to prove, that x minus 1 over 2 squared plus y minus 2 over 3 squared is equal to 1. Example 6. Given that x equal to 1 all over 1 plus cos t and y equal to 1 all over 1 plus sin t, Prove that x minus 1 over x all squared plus y minus 1 over y all squared is equal to 1. Proof. From the first equation, upon cross multiplication, we have x plus x cos t is equal to 1. Then, making cos t the subject of formula, we have cos t is equal to x minus 1 all over minus x. Also, from the second equation, upon cross multiplication, we have y plus y sin t is equal to 1. Also, making sin t the subject of formula, this will give us sin t is equal to y minus 1 all over minus y. Squaring this and then adding, we have x minus 1 over x all squared plus y minus 1 all over y all squared is equal to cos squared t plus sin squared t. Then, by the first fundamental trig identity, this is equal to 1. We have thus proved that x minus 1 over x all squared plus y minus 1 all over y all squared is equal to 1. This is the end of our lecture 4. Thank you for watching, and keep on watching.